Hello and welcome to another tutorial. We are going to continue on discussion on the methods of classes and what are the best practices of declaring methods and what are the details about what stuff we should care about when we deal with methods. So now we're going to look at passing primitive data type arguments, and primitive arguments such as int, double are passed into methods by value. This means that any changes to the value of the parameters exist only within the scope of the method. When the method returns, the parameters are gone and any changes to them are lost. And again, this goes to the fact that Java is, first of all, the JVM, Java Virtual Machine, is a stack-based machine, which means each method, when it's called, a stack frame is created, and then the local variables and the parameters are put on the stack, and then when the method call returns, everything on that method stack frame is destroyed, and then the stack frame is said to be popped out of the memory, right? So Java is a stack-based machine, and the memory required for the stack of a stack frame of each method is separate from the Java heap, right? So it's kind of like two separate things. Whenever you create new objects, allocate memory using the new operator, JVM puts them on the Java heap and manages all those objects there. And then on the stack, there is always a reference or a pointer to that actual memory location on the Java heap, right? So a stack is supposed to be much smaller than the heap. That's also the same even for the hardware level. Like if you compile a C++ code to a machine code, when you execute it through the operating system, it's the same thing, right? Every program, every process gets a stack memory. On Unix operating system like macOS and Linux, it's usually the maximum is 2 megabytes of a stack. And you are, I guess you're also very familiar with the famous error that we see in Java, which is called Stack Overflow, right? You also get the same error in C++ programs, right? And operating system process, but usually those end up in a segmentation fault, and that's a signal that, hey, we ran out of memory or something bad happened to the memory, right? And then the program terminates. In Java, you just get a JVM error. The JVM panics, and then it basically terminates, and you get a stack overflow error. Now, what's the meaning of passing by value? And let's have a look at this example first. So we have this class, and we have a main method. It takes one parameter, which is a string array. So it's a reference type. It's an object. We have this local variable x equals to 3. And then we have a static method, which returns type is void, takes an integer, and then does something to it, pass method. So what this does, if we call it with this x variable, what JVM does, JVM copies this value. And obviously x is just a variable. A variable is a placeholder that holds the value, right? A primitive type. So copies the value of x into here. Like this is equivalent to saying pass method round bracket 3, right? It's the same thing. And then that 3 is going to be copied in this local variable p. And then if we assign p to 10, obviously now the value of the local variable is 10p. But then once we return from this method, after this line 9 is executed, at line 10 we already have returned from the call to this method, right? So the stack frame of this method is destroyed, which means this local variable doesn't exist anymore. So it doesn't matter if we set it to 10 or not. Now, the reason we say that Java is passed by value, which it means that this x, after we return from this method, it still holds the value of 3, because this x was different from this p. The value of x was copied into p, but x itself is not changed. Even if you change this value of this p inside this method, it doesn't matter. If we say after invoking method, x is still going to be 3. Because the value was copied, not the actual variable. Now, in other programming languages like C++, you can pass a variable by reference. And then when you come back, the actual value is changed. And the reason that C++ allows that is because C++ has the concept of pointers even for primitive types. And I will show you an example on how to do it. So let's create a new class and call it pass by value. And again, I want to emphasize that this is a very, very important topic. for basically Java programming language. If you really want to understand Java, this is one thing that you have to really understand. And this gets complicated once we also pass like reference types to references to objects to a method. Then things are a little bit trickier, and I will show you exactly what happens, right? For now, let's just first start. Let's just copy and paste this main method in our pass by value. All right, and then this static method, let's copy and paste it here after the main. So we have a static method. It takes a parameter, and again, each method gets its own stack frame. Basically, a memory area that holds the parameters, right, into a stack data structure. And then so we declare this variable, and then when we say pass method x, this is equivalent. So this is basically equivalent of saying that pass method 3, right? So basically what this x and 3 are basically the same thing. And when you do this in actuality at runtime, what JVM sees is pass method 3. So it means that when we go into the stack frame of this method, this p is going to be initialized with 3. P is initialized with the argument that is passed to the method at the call site. So when we call a method or we invoke it, we say basically we call it, and the call site means where we actually call this. So this is the call site of this method, this line of code. And then what happens here is that now we're saying that p is a variable, is a local variable associated with this method, right? So when this method is called, a stack frame is created, p is pushed to the stack with a value of 3, and then we set it to 10, right? And then once we return, that that stack frame is going to be destroyed. So there is no concept of this local variable p. So when we hit line 13, this x had nothing to do with this method call. Although we pass it to the method, what actually happens is that the value 3 is going to pass, right? That's the whole meaning of variable. But this variable in Java has nothing to do with this variable p, this parameter, right? And so you have to be very careful. And again, that's because, again, pass by value means whatever variable you pass to JVM. Actually, JVM, in reality, the value of that variable is going to be passed behind the scenes. You might not see it, and obviously, it's better to work with variable in the source code, right? As a developer, when you're writing your source code, it's easier to say x, have very meaningful, basically, you should have meaningful and easy to understand variable names, right? So that you can later quickly use them. For example, you can have another variable, age equals 25, and if you want to call this, and remember you want to have a method that takes some age and does some calculation. So, and then you can say pass method, right? Pass method, and then you can easily realize that yeah, there was a variable age or my age or something like that. So it's very easy, right? And again, always rely on the autocomplete feature of your IDE, so that you only type the first few letters and it automatically shows the appropriate suggestions. And again, pass by value means at runtime, when this method is actually called at the call site, what happens to the JVM is what JVM sees, it doesn't see the pass method my age. Instead, it actually sees the pass method 25. That's the meaning. And this 25 is going to be initializing the local variables, and this has nothing to do with the original variable. So if this local variable that is initialized with some value at the call site when you call the method, and you change the value that this local variable holds, it doesn't affect the value of this variable, because this variable had nothing to do. This was a placeholder for the value. When we call the method, JVM copies whatever value that this variable has, and then that's going to initialize the local variables in the stack frame of this method. All right, I hope this is very clear. And obviously, if we run this, the value of x is not going to change. It was 3. we pass it to x, pass it to this method. X had nothing to do with this call, right? X was a placeholder. And when we run this code, JVM sees this line that I highlighted, pass method 3. 3 has nothing to do with this variable, right? The job of this variable to be a placeholder for this value. And when we call a method, the value of the variable is going to be copied basically the value of the variable is going to initialize the the local variables. And once we return from the method call, local variables are destroyed. It doesn't matter. So the original variable is the same because it had nothing to do with this method call. Once we are inside the method, the variables that were passed as arguments, they had nothing to do with this method body, right? They don't exist. Only the local variables or the parameters exist in the method body. After that, when we come back, the variables that we originally passed and arguments, they are unchanged. You can never change the value of a argument when you call a method, and then when you come back, those changes never take effect because Java is passed by value. All right. And so let's look at let's also comment this warning. So we have, we declare x3 and then we pass to a method. And again, the value of x is going to be copied. X has nothing to do with this actual call. It has nothing to do with the body of this method. Whatever that happens in the body of this method can never affect the argument that we pass. And let's have a look at the bytecode to see what happens. So pass by value. All right, and let's see what happens in the bytecode. So let's zoom in, and then let's put this side by side. So we have a type in the which is identified as a class, and the name of the type, again, it's not the name of the class that we declared in the source file, but it's the fully qualified name, including the package hierarchy, right? And then we have we didn't declare any constructor, but compiler provides a public default no arg constructor, and all it does, it calls the superclass constructor, which should always happens. Java compiler always enforces this, that the superclass of a type or the super type of a type has to be always initialized before an instance of the type is constructed, right? And we know that if we don't explicitly mention a class extends something, it means it extends object. So this is explicit. It never changes anything in the bytecode because that's the implicit assumption. So we just call the constructor of the object and we return, right? So yeah, in this example, we don't really care about the constructor, but just know that it's there, right? And what is the next one? So we have a main method, and we already have seen how the variables are going to be initialized. So I'm going to remind you again. So this is an assignment operator, and we are declaring a variable and immediately initializing. So for assignment operator, the right hand side is going to be evaluated first, and the return value of that evaluation is going to be assigned to the left hand side. So the right hand side is not an expression, it's just a constant integer literal. And we saw that for integer literals 0, 1, 2, 3, 4, 5 and -1, there are hard coded bytecode. So iconst _3, and we saw that this iconst something applies. These are the special bytecode applies to -1, 0, 1, 2, 3, 4, 5, right? For these range of integer literals, there is a hard coded bytecode. So iconst3, and then we say that this variable, this parameter takes the first location on the stack frame of this main method. Remember, main is method, it's a static. We saw that if a method is a static, a pointer, this pointer is not going to pass to the stack frame, right? So the first, when we call a method, the first thing is to pass, put the parameters in the order that they appear into the stack frame, right? So basically what happens here is that once that happens in the bytecode, we see that we iconst3 and then I store in location 1. Why location 1? And again, because location 0 of the stack is this args variable, which is a object type, a reference type, right? and reference types are 64-bit. But we know that by default, again, this is a advanced topic, by default, recent versions of the JVM use basically compressed references. I believe it's called compressed oops, something like that. What this means is that as long as the address space is enough for 32-bit memory addresses, because reference types are syntactic sugars for the pointers, and on a 64 machine a pointer is going to be 64-bit, but the stack of the JVM, because of the historical reasons, it was 32-bit, which means if you're going to pass a reference type, push it to the stack frame, it has to occupy 2 locations on the stack, because each location is 32-bit. But because we use the JVM by default uses compressed references, which means it tries to use 32-bit addresses as long as it's possible. If your application, for the total lifetime of your application, you never need to have more than 32-bit for your address space for the Java heap, and stack frames. Then basically even reference types take 32-bit. So in reality, this reference type has to occupy 2 indices on the stack, 2 locations, and then this X should be at location 2, basically index 0, index 1, index 2. But because JVM tries to use 32-bit compressed references, then this occupies 1 location, index 0 on the stack frame of this main method, and then X becomes index 1 on the stack, right? So this line of code, assignment operator, declaring X and initializing to the 3, it's going to have translate into 2 bytecodes. Load the constant 3 and then store it in the index 1 of the stack frame, right? Now what happens here, this is a method call, and the first thing that happens, because we're passing a variable, not a literal, JVM is going to load the value that this variable holds. I load 1, which means load the integer value. Let me put it in a comment, right? And that value, then it becomes like this line that I highlighted, pass me 3. It has nothing to do with the X itself. It just says, hey, go grab the value that X holds and then call the method with this value. And this value is going to be initializing the value of the local of the parameter, which is a local variable for this method. It has nothing to do with X. So you can never change the value of X inside this method. When you return, the value of X is always whatever it was before, right? Because there is no way for you to access this variable in the method call, right? So I load 1 and then invoke a static. We're going to basically call a static method or invoke it. I mean, the name of the bytecode is exactly telling what's going on. So we're going to call a static method, right? Get a static, and then obviously the other lines. So this line for calling this method translates into 2 lines of bytecode. 1, get the value that X holds, and then this becomes like this, pass method with the actual value, and then we go and call it. So this is called pass by value. We get the value that the variable holds, and then we call the method just like we actually had used some sort of literal. In this case, obviously it's an integer literal, so it translates into this, right? So if we look at the, first of all, let's look at the local variable tables for the main method. So if you look at the local variable tables for the main method, we already know that there are 2 local variables. One is the parameters, which is at index 0, and then X, which is at index 1. So args is at index 0, and then the type is Java lang string. And again, args is a reference, so it's a pointer, and it's supposed to be 64-bit, which means it has to occupy 2 indices on the stack. But because JVM by default uses compressed references, which means 32 bits, then as long as your application doesn't require a 64-bit address space, then your references only occupy basically one index on the stack. And X is at index 1 on the stack frame of this method, and the type is int, right? And then So let's look at the method, what happens actually in the method call. So in the method call, we have, it's a static method. So it says that a stack only has one slot because the only parameter is int, which is 32-bit. And a stack, every slot on the stack is also 32-bit, right? And it has one local variable, which is just this p parameter. We push 10 to the stack, and then store it at index 0. So we load this 10, and then we store it at index 0 of the stack, which is p, and then we return. That's it. And the local variable is p at index 0, type is in. Now, first of all, know that what happens if I change this to long, because long is 64-bit. And note what happened to the stack. Now it says that this stack frame of this method requires 2 slots, but we still only have one parameter, right? That's because long is 64-bit and it's a primitive type, not an address type. So JVM cannot use compressed reference because p is not a reference. So long is 64-bit. A stack in a JVM, because of the historical reasons, is 32-bit, right? So if you want to push a 64-bit integer to the stack frame, you have to divide it into 2 pieces, right? The first 32-bit and the second 32-bit. So, and then unfortunately that requires that you have to have a special, now you cannot just say load a 10 integer, you have to tell it, treat this 10 as a long. So load a constant 2-byte wide. W means wide. These are wide integers. Wide integer is an integer that doesn't fit in a slot of the stack, which is 32-bit. So it's a wide. It's similar to like wide characters in C++. You have C out, console out, and then C out or W out, something like that, which is for wide characters. Characters are 16 more than 1 byte, right? Same here. It's saying that this integer is supposed to be 64-bit or a wide integer. So we're loading a constant, and then you have to treat it as a long integer 10. And then we have L store 0. L means store a long integer. So the bytecode is L instead of I. I was for 32-bit integers. L is for 6. But we don't get a compilation error for when we call, because 3 is going to be copied into the method, and 3 as an integer literal is compatible with long, right? Which means 3 can be treated as integer by default or converted implicitly to long. Now, what happens here is that nowhere, and by the way, there is this extra bytecode that now you see here. Here now, after we load the value, because x is still an integer, so we say that integer load at index 1 x, but then now we have to convert integer 3 to long 3. That's why we get this extra bytecode I to L. I to L means convert the loaded int value to long value, because the signature of the method has to match, and JVM automatically does this for you because integer can be implicitly converted to long. But the rest of the bytecodes are pretty much the same, right? So we only get one extra bytecode for converting it to long. If that's why we say that if you think that your application doesn't require 64-bit integers, always try to avoid those. But sometimes you want to stick with long. For example, there are some use cases that you have to stick with 64-bit integers. Now the question here right now in the bytecode, we don't see where actually this local variable p is going to be initialized, right? In the bytecode, in the actual bytecode of the main method, we just say call this method, right? And in the declaration of the method itself, it just says that it executes. Basically, it doesn't show what happens when we call. Behind the scenes, what happens when the JVM hits this invoke a static, which means call this static method. Behind the scenes, it before executing the bytecode for the body of the method, is going to create a stack frame. It's going to copy the value of 3 into this. So basically, once we're here, right after we enter this, the value of p is going to be initialized with whatever value we passed at the method call, which is 3, right? Again, x has nothing to do with p. That's just because to the JVM at runtime, this highlighted line, pass method 3, is what actually JVM sees. JVM doesn't see that you wrote pass X. JVM sees that what you meant was pass 3, pass method 3. That's why JVM loads whatever value is in X. And after that, the method call is like having the method with the actual numbers. So JVM doesn't care about the variables. It only cares about the values that those variables hold, and those variables are going to initialize the local parameters or local variables of your method, and then once you return from the method call, the variables that you had, they're not going to change, right? You can never change those variables. So I hope you enjoyed this lecture. In the next lecture, I'm going to discuss the topic of pass by value for reference types, object types. And there is a subtle difference or nuance that you have to be very careful about. So please stay tuned, and I'll see you in the next one.